So hi everyone, my name is Karun and I'll be your guide for this evening, for this day. Over the next hour and a half, I'd love to talk to you about some of the things that have been, fairly popular in the market over the last year and a half. There's been a lot of hype. I'm going to cut through some of that and talk about, as engineers, what are the things that we should know? What are the things that you should focus on to be able to build skills fundamentally and sort of look at this sort of wave that's the sort of recent wave that's coming in, and how to kind of capitalize on it and upskill yourself to be sharper in this space. So, quick question to everyone who's sitting here. Quick demographics check. Everyone works in tech, I'm guessing, right? Mostly devs or a few other roles of the sort. Yes? Everyone involved with software delivery? Everyone been doing software delivery for a while, like at least a year or so or more in most cases? Great. I know there'll be some people usually who are from college as well. That's completely okay. Because the question I'm going to ask is going to resonate more with people who've been in delivery for a while. So, what are some of the hardest parts of software development, right? Where do you tend to have the most amount of challenges? Where do you spend the most amount of time, effort, most amount of effort to try to resolve things? Like you build something and then you realize something went wrong. Which part of which activity in software development is where you think you have struggled mostly with? So fixing the bugs is one area. Architecture is another. Anyone else? Vulnerabilities is another. Yes. Cool. That's a good sample, right? I'm actually happy that, like, mostly when I ask this question, in the past whenever I ask this question, mostly people put their hand up and say, I spend most of my time in writing code. And I get that, it's a significant part of what we do as developers. But it's really refreshing to hear that that's not where most of the challenges are, right? So if you, and one of the things that I want to drive home towards the beginning is that software engineering isn't just writing code, right? There's more to it than that goes into it. And like you guys are a good sample of, like some of the stuff that you talked about where your pain points are interesting areas, because you do have challenges with vulnerabilities, you do have challenges with bugs, right? And if you think about why you're having sort of these sort of challenges, and if you look at sort of overall where our pain points are, problems are because of different reasons. If you go through sort of the 5 whys exercise of why you're facing these challenges, quite often requirements are unclear. There's a fair bit of design churn, right? Like you make a decision, you think about a certain design, realize that you need to tweak it, and iterate over it over a period of time. Sometimes your understanding of the requirement was incorrect, right? So you got requirements, it seemed clear at the time, it was just that you misinterpreted something and didn't clarify it well enough. Sometimes our release process might have challenges, especially if the product is brand new and is just getting set up. The release process itself might have challenges, which might ensure that, which might cause bugs effectively when sort of taking things live. So there's problems which could happen at different parts of software delivery. And if this is the case, like if you go back and kind of look at AI assistants over the last year and a half, right, or 2 years, which has been in sort of the media, there's been a lot of hype in the media about some of this stuff. Most of the stories that come out are about like development. Most of them are about vibe coding. Most of the hype is around, it's so much easier to build now. But that's not where most of our pain is, right? And so if you start focusing a bit differently, why don't we solve the hard problems, the places where we are struggling, right? Like the design issues, like the bugs, how do we reduce them? How do we look at vulnerabilities? How do we look at making sure we understand requirements correctly, making sure we have clarity so that you have lesser challenges. So off the bat, I did want to talk about the focus shouldn't be on making it faster for us to develop code. The whole point of this is that we start thinking more clearly. Slight rephrasing of why we use the tools, but most people focus on velocity or the ability for us to deliver. What I'm going to ask all of us to, through this conversation, I'm going to talk about a bunch of examples, but the aim is going to be to make sure that we are delivering correctly, right? That our thought process is better, that we are having less of these challenges in different phases, and use these tools across the board, not just in the development phase where you're just trying to make sure that your requirements are getting met. So before we do that, let's take a second to talk about how our craft is changing, right? Like as devs, most of our skill set is around how do we develop code. And these tools effectively are our generation's IDEs. So for anyone who's been writing software long enough, in the early 2000s, a bunch of IDEs came in. And I'm sure at that time as well, there were, not that I was writing code at the time, I came just after the IDE revolution, I guess. And for me, it was always a given that you'd use an IDE. It just seemed obvious. I'm sure there were folks who still wanted to use simple text editors at the time because they just were more comfortable with it. But over a period of time, for those of you who are younger, you would have noticed that that conversation doesn't really happen now. I'm fairly confident that 20 years, 10 years, 20 years from today, we'd be talking about something similar. This becomes a core part of our infrastructure to say, yes, I am going to use tools like Copilot, I am going to use things like Claude Code, whatever your tool of choice is, tools will change. The underlying methodology will not. And so one of the important things for us is, what are the skill sets that we need to have so that we can actually make use of these tools better? Right? So let's go through a quick skills guide of saying, here are some of the principles that we need to learn, because this will kind of make sense in terms of like how we are trying to grow as people, as devs. So don't focus on learning the AI tools. I know it sounds tempting to just focus on, I have not used Copilot as well, I want to understand how Copilot, how I can become better at using Copilot. Or Claude Code, right? Insert tool name here. That shouldn't be your focus. Your focus should be, how do I become better as an engineer, right? How can I use, like what are the fundamentals that I need to know? So here's a quick skill map that I try to draw, and these things change fairly quickly, but I try to write it in a way which is a bit more generic so that it lasts through the cycles of change, right? More things might be added to this, will definitely get added to this. Over a period of time, but what's on board hopefully just stays. So there's two columns that I thought we should draw out: skills on the left, examples on the right. And one of these examples, I'll go top to bottom from like what as devs we think of first. If you've heard of sort of on the advanced side, people tend to look at multi-agent systems and really become fascinated by all of the gains. Like, have you heard of multi-agent systems? Not from like building a systems perspective, but actually doing software development. If you've heard of Claude Code and what you can do with sub-agents there, it feels pretty magical. And the first time you see it, you think, great, I'm going to take a story, just give it to this agent, and it's going to take care of everything. I fire one prompt, get up, go, play table tennis or whatever, and it just finishes my story. But the truth's not quite there, right? When things don't work, you need to be able to sort of look a layer below and try to understand why these things don't work. So an example of some of the things in a layer below is actually split that problem up in terms of sort of software engineering architecture, software engineering applications. So look at how these tools will work differently in different phases or different activities in software development, through your requirements, through your development, after your deployment, development as well. This part will make a bit more sense a bit later. The layer below this is sort of the system layer, as I'm calling it. Here there are some techniques that you might have heard of. If you've heard of RAG or retrieval augmented generation. So RAG is one of the techniques a lot of people hear about. If you want to do multi-agent systems, you need to know agents first, right? It's one of the prerequisite. A lot of people talk about prompt libraries as well, and we will touch on this a bit later. But the real thing I feel like most people don't tend to focus on, and some of these are fairly, core practices. And I've listed two out. You could make all of these a lot more deeper and go, left to right on more skills. But two of the main things we should talk about is prompting and context. These are things that some folks would have already been introduced to. There's enough and more information on the internet about how to prompt well and how to manage context well. So we're going to talk about some of those patterns because quite often that's not as obvious in terms of like which pattern should you use and when you should use it. Now if you're curious, you don't have to stop here as an engineer, right? You can go even deeper. So the layer below this are like foundational concepts, And we've talked about this in previous dev days where we've gone into details of how LLMs work. But a quick summary of a couple of those is like examples like tokenization, embeddings, etc. are all good ways to be able to understand why the LLMs are doing what they're doing, how they're able to actually operate, right? And if you've attended any of the previous talks from other speakers here on this floor, you would have heard them talk about some of these concepts. We won't be going into these yet, but what I'm trying to get people to understand is it's not just prompting and context management that you should focus on. At some point, if you're curious about why some of these techniques work versus don't, it is useful to have at least a basic understanding of what the underlying concepts are. The deeper you go, the better your understanding of why your prompts are doing the right things versus not, why your agents are actually working correctly or not, right? And building that sense is fairly important because otherwise it feels fairly magical. I sent a prompt, it worked, I don't know why. I sent a prompt, it didn't work, I don't know why, right? So when it works, you're really, really happy, and when it doesn't, you're not. And that's one of the key problems that I'm here to talk about today and try to address. So let's talk about some prompting techniques really quickly in the intro, right? Here we'll just talk about them, and later we'll see examples and when you apply which technique, why something works better in some cases versus not. This list is fairly long. If you go on the internet, I can share resources later after this talk as well, where there are entire websites explaining these techniques, not necessarily from a software engineering perspective, not necessarily from if I want to use a Copilot or Claude Code better, how would I use these things? But they do explain the context inherently from the perspective of LLMs. So as long as you're able to understand it, you're fine. But I'll give like a slightly modded explanation of the same thing. First one is zero shot. These are usually the type of prompts where you're asking for something. I need you to build X, right? You're just asking what you need directly and hoping that it has enough context that it's able to actually execute the talk. At the offset, these sort of prompts quite often are not as effective if the scope is broad. If you're asking for a very wide range of things without being super clear about them, it's not going to work as often. But it does work very well if your request is fairly limited. Like for example, if you build the context on exactly what you need to build and then ask, can you please just go execute this task, right? Can you write the code to make this happen? It'll do a pretty good job at it. So it's one of the first things most people rely on, but quite often we forget that you need to give it the right context. And we'll talk more about context a bit later. Next thing is few shot prompting. I would be surprised if a lot of you have not heard of this, but effectively what you're trying to do here is you're trying to give it examples. That in this case, this is what I would do. In this case, this is what I would do. Therefore, when you need to do something else, how would you solve this problem? And effectively giving this context, it's able to make a relation saying, if this was the question, like for example, if you ask the question, let's say there are 3 white balls and 2 black balls in a bag, and you take 2 white balls out, how many balls do you have? And if you ask that question directly in a zero shot fashion, you might not get the right answer. LLMs are not great at arithmetic. If you know the underlying structure of how they operate, you'll know why. But if you do the same thing with a structured series of examples, right? If you give 2-3 examples and then ask the same question, it'll end up working. Because you've kind of given it the logic of how and with an explanation even more so, it will be able to predict what the answer is better. So quite often, if you don't get the right answer, the point is you didn't sort of, for lack of a better word, like teach it, that here's the correlation between my question and here are some sample examples of what in other contexts would have worked. And here you're trying to talk about, if these are the correct answers in these scenarios, what should I do here? We'll take an example of this as well a bit later. The next one's chain of thought. If you use tools like those development tools before, you would have seen this in action in the last 12 months or so. It's become fairly popular that all of the tools across the board, including the open source ones, have adopted this. You ask a question, it will give you the rationale, it will give you the thought process of what it's doing, and it will break everything down into a chain of steps, right? Here's what I'm doing, here's why I thought what I thought. And that also helps you validate. It's not just a magical answer you got at the end, right? It has told you what the steps are, because that allows you as a user to read it and then say, I can see why you went wrong. Therefore, it is easier for me to talk to the agent I'm working with and explain to it where, in my opinion at least, you went wrong, and then be able to correct it. So chain of thought is fairly popular over the last year or so in this space. Another example is meta prompts. Quite a few people know this technique and it's fairly powerful, and I'll show you an example of, like actually a couple of examples of where you should use them. But meta prompts, the simplest example you can take, though it's not super accurate, is you can use prompts to make prompts better. So for example, when you need to give a prompt, you've been trying to prompt and the system doesn't give you quite the output that you need. You could ask the tool itself to help you refine the prompt. Here's what I want to solve, here's what I want to do, here's the prompt I'm writing, what is it that I'm missing here? Can you help me make this prompt better? And this is one of the things which makes LLMs different. Like every other tool, you can't ask Excel to make Excel better, you can't ask other tools to make themselves better, but because of the way LLMs work, you can ask it to make the prompt better. So it's kind of you help me help you sort of scenario, and it's fairly powerful. So yeah, so once you get used to that, it becomes like a nice hack to say, my prompt didn't quite work, let me take your help to make my prompt better so that you can do the right thing for me, which I think is beautifully poetic. So yeah, now here's what we'll do. Let's actually start taking a few of these examples. Let's walk through how you would use some of the prompting techniques we talked about, and through that I'll also talk about context, how you would manage it, etc. Through the development phase. And I've divided the different things you do during development into 3 major blocks: before development, during development, and after. And we'll take examples of how you would use some of these techniques. This is not an exhaustive list, right? So it's meant to give you a sense for how you can use these tools. So the first thing we want to do is actually looking at using AI as a partner to be able to solve problems. So it's not just me delegating tasks to you, I want to actually pair with you. So if anyone's done pair programming before, if anyone works at a place where you practice XP, you might be used to doing pairing, right? I look at these tools as another pair. Human pairs have their own benefits, so do AI pairs, and maybe that's a debate we take offline or during the end of the conversation about when I'd use which one, but both of them are fairly useful. And so with AI pairs, you can take a couple of different examples, a couple of different bits in the sort of design and requirement phase that you can look at, right? So you can use these tools to actually sharpen how you're looking at requirements. You can use it to make your design better. You can have trade-off conversations, right? Quite often on teams, when you're trying to build a new feature, you're trying to design something, which is I think what you were talking about, right? One of the biggest struggles is your design is only as good as the opinions in the room, right? So I've been on teams where, like when I was younger, like a couple of us who are roughly the same experience would debate about a design and say, yes, this is how it should work. We'd go and try to sort of talk to other people, and then suddenly that plan falls flat. And the reason why that happens is I think the opinions in the room are only so diverse. And when your opinions in the room are not diverse, the answers are not as good as they could be. And this is one of the things that AI systems do a lot better, because they've been trained on a very wide variety of data sets. So they will have contexts about things that we might not have taken into account, or we might not have sort of pictured together. So it's a great way to actually get feedback. One of my favorite things to do actually is not development, it is to actually use it for requirement analysis and design. Because when you do that better, your entire development becomes a lot simpler. Making sure that you're framing requirements well, right? If you've heard of this before, there's a term called problem framing. If you frame a problem well enough, you solve the problem a lot more easily. So if, for example, you're trying to groom a story, right? If you make sure that you have the right problem in mind and you're solving the right problem in the right way, I think that if you groom really, really well, the execution of the story is fairly easy. So yeah, you can use it for a bunch of other things which I have up on screen. Rather than bore you through some of those points, let's actually take an example, right? You need a quick system. So think of a simple task tracking system, named it flow track for whatever random reason. Feature set is fairly straightforward. I want to paint a picture for you of what a system looks like, an existing system, and then we'll take a story card and actually walk through examples of what works and what doesn't. So in this system, users can do a quick sign up, add tasks, manage them, etc., and even work with teams, right? So you can create a task, you can assign dates, you can share tasks with teammates, effectively meaning it's a collaborative tool so that a team can have like a shared task list, right? No, I don't have code for any of this. This is just like a sample system so that we can all visualize something fairly straightforward. There's an admin functionality as well where you can manage users, which is fairly straightforward. There's a tech stack down there as well in case you want to look at it. It won't matter for the story you're playing. But yeah, this is what a rough system kind of looks like. Let's talk about the change we want to do. One of the problems is that one of the problems in this fictitious system that we are trying to do, and this is the business requirement, like the requirement that's come from the business, is when teams are sorry, when teams are starting to use sort of the pro versions, and they've kind of bought the pro plan so that they can collaborate with teammates. They actually buy the pro plan but are not able to find the invite feature quick enough. So the first thing you would do if you pay for a pro plan is you would want to collaborate with people. So if you upgraded for that intent, the invite flow should be fairly obvious, and what, let's say, the users have, the folks looking at the analytics data have noticed is that that's not happening. People are signing up and then struggling to find where the invite functionality is. So very few users actually end up inviting their friends. This is the problem we're trying to solve. Now, the plan seems to be that we are going to create a setup wizard. So when you sign up, when you're setting up the entire thing, it will kind of guide you through the flow and help you indicate that there is an invite flow, help you indicate this is how you should walk through it. And it's basically like an assistant on your app, which is walking you through the feature set. Now, how the business came to this conclusion is outside the scope of the conversation, but let's say that's the solution they're looking at. They have a couple of constraints that you don't want to delay the sign up flow. You don't want to hold up the entire sign up process. So if somebody signed up, it should continue to go as seamlessly as it always did. So it shouldn't, any of the setup wizard stuff should not hold you back. But there's a bunch of questions at the bottom which are unknown. We don't really know how the user experience should be designed. Like, we don't have an opinion yet. So when the business talked about this, they kind of left some questions unclarified. And in a certain sense, this story is not fully groomed, right? Like, if it was groomed, you would have these answers. But sometimes if you're working in a product company, people would come back and say, this is what I know so far, can you figure the rest out and can we iterate over it? Because we don't always have the answers that we need. So let's say this is the card that you get, right? Let's assume that you're fairly new to the system because you just heard about it literally 5 minutes ago. So it's not like you've had a lot of time to prepare about this story. So one of the first things people would do is, let's look at an example of a prompt, right? You try to ask what are the clarifying questions you want to ask before I can build anything on the story. Fairly common question to ask, right? Because you can see there's a bunch of open questions. I don't know, and Karun, you've been talking about doing a bunch of these, use your AI assistant as a pair and kind of get a sense for what works and what doesn't. So we ask it that question. Now it will ask you 4 more questions which seem okay, right? Like, should the invites happen before or after the onboarding? What order do you want to do this in? Do you want to notify people, etc., etc.? The questions aren't great. It's not really moving the conversation quickly. You can go down this route. For anyone who's used these systems, you'll spend probably the next hour and a half having this conversation back and forth, maybe a bit quicker if you can type quicker or if you're speaking to it. But the conversation won't move as quickly, right? So the thought process, in a certain sense, is a bit shallow. Like, the questions that you're getting back are not detailed enough. Now, this is an interesting point at which I feel a lot, like, has anyone faced anything of this sort where you're getting a set of questions because you did ask it to ask questions, you're getting questions but the questions are not detailed, right? I've noticed when I've worked, like we worked across teams, and some of those people are sitting here today. A lot of us tend to get like a little bit annoyed with the system at that time. I don't know if you felt this as well. Yeah, I asked you the question, this thing is not smart enough, it's not giving me good enough suggestions. And I feel like we actually spent some time thinking about why. Why are we getting annoyed at the system? It's a tool, right? Like why are we in this place where we're getting annoyed at it? And one of the things we realized is because we think of these systems as tools. And the thing is that when tools don't work, you're unhappy about tools. One of the first mindset shifts I would want all of you to have is, while these tools, like these systems are soft pieces of software, try to think of them as the same as what a teammate would be. So for example, if I'm working with a teammate, I ask the same question and I get a fairly shallow answer. Would your immediate response be, hey, your questions are not deep enough, like you've not thought through this problem? Or would you think, hey, this person has just joined the team, clearly this person doesn't know any better. They've not had the time to think through this problem well enough. So I didn't do a good enough job of onboarding you yet, right? Which of the two do you think you will react, former or latter? Right? Latter? Good, because that's how mostly we treat each other, right? If you don't know, it's because I didn't onboard you well enough. So one request, let's start switching that mindset, start using these tools as, like, I'm not saying talk to them as people and build relationships with them, that's not really the intention. What I'm asking for is though, give them, like when it doesn't get you the answer that you want, think about what's the context that I didn't give you. What's the information that I could have enabled you with? Did I ask the question well enough? Because if this was two people, I will assure you each and every one of you would think through those things. If I didn't ask the question well enough, then you wouldn't have answered it well enough. If I didn't tell you the information, you wouldn't give me the right answer. So please give it the same respect for a second, and then let's see how the answers change. So let's try a slightly different version of the same prompt. Intention still the same. I want clarity on the stuff that I don't know, and I need another person to think through this, right? But this time, I'm setting a slightly different context. I'm saying that you are a product engineer. Your goal is to make sure that you have clarity before you execute anything, right? And most of these tools have a plan mode if you've seen them. If you're using something like Claude Code, Shift Tab is the shortcut. It will not write any code, it will just think. And it's good to put it in that box sometimes to make sure that you don't proceed and you don't build anything until you have clarity. So then this time I'm saying, please make sure that you clarify your behavior, you identify assumptions, that you ask questions about these specific bits, and until you have information, please don't move forward, right? Now I've given it a structure on how to think. Think about what the missing acceptance criteria are, help enrich the story, and make sure you have the right information before you move forward, right? Another thing that you can do here, which I couldn't fit into the screen as well because it will make the question longer, is also give it the right context. The assumption here is that you've linked up to something like assume your story is on GitHub, GitLab projects, or Jira, or whatever other tool that you have. Usually these tools have something called as MCP. I won't go into detail about this, but effectively think that you've connected your system, your Jira or whatever else, into this tool so that it can access stories better. So what you could do is you can just actually go and mention the story number, it will pull the story content in automatically. But the moment you can do that, you can also enable a bunch of other things, right? You can run this prompt, you could run this on ChatGPT, for example, right? It doesn't have context of the project. It just has context over the story at that point, because if you copy pasted the story. Imagine you're doing this in something like Claude Code, it has access to the entire code base. And I know this sounds a bit obvious, but please do it inside the repository. It has access to code, it can think better, it can understand things better. The answers will be incredibly more accurate. Each of these tools also works differently and scans the code differently. So please make sure that, if you're using something like Copilot, add the specific files so that it gets context, and it's cheaper that way. In Claude Code as well, if you do add the specific files, it will be better. Like the results will be better and it will be a lot cheaper. But Claude Code is actually pretty good at being able to scan repositories and find the right context. And most of the time it will get it right. And when it doesn't, just please help out and add the right file. Building the right context is important. it's no different than what you do. You can't pick up a story until you understand what it is that you need to do, right? Most of you will spend some time reading the code first. These tools are no different. You will spend some time understanding the business first, making sure you're solving the right problem. These tools are no different. They also suffer from a form of amnesia, which is interesting. So if you've never visualized something called as context, we should spend some time talking about it, because if you tell it something, it doesn't mean it will remember it forever. Like for example, because we've had this conversation 5 minutes in, if I ask you what was the original story, I'm fairly confident each and everyone will like repeat about 80% of what that story was, right? Because you can remember something 5-10 minutes or even like an hour or two later. Context windows here are limited, and each of the LLM models work differently. So they have basically different amounts of memory. Imagine them as RAM. They're not quite that, but if you sort of fill it with a bunch of stuff, the old stuff starts moving out. How it moves out is a technique called compaction I don't want to get into, but there are other techniques to be able to manage some of these bits. It's going to start dropping stuff after a while, and that will mean that your accuracy is going to drop. Just know that these things happen. Things like Cloud Code will actually tell you this, because on the bottom right it tells you when it's about to run out of context, and there are ways to manage it. We'll get into some of those techniques a bit later as well when we do the demos. But when you ask it to analyze a story like this, because you've given a structure, because you've given it the right context, you've hooked in the right set of things, the responses you're going to get are significantly better, right? This time, because you gave it a structure, it responds in the same structure. You've given what you are expecting better, right? Earlier thing was you asked it to ask clarifying questions, it just asked you questions. Now you said, ask the questions, make sure you clarify assumptions, make sure that you are talking about a bunch of other details, so that then you can go into checking the assumptions and making sure they're valid. And if they're not, you can call them out. The follow-up step of this conversation is going to be the same way as you and I talk to each other, right? So let's say I'm the one which has context on flow track, and one of you is the newer person on this. If this is a conversation you and I would have, if I ask you to list assumptions and you say these things, I could go back and say, hey, assumption number 2, for example, might not be correct, right? And then you will add more questions. Achha, then what does this mean? What else should I be looking at? What else should I be thinking about? Those become important. And the clarifying questions, effectively, it's my responsibility to add more context. Keep doing this back and forth. You're giving the tool the right set of context. Now, let's take a second to talk about why these prompts has really worked. And then we'll later get into what you should do next, right? So, first thing is you provided context. You gave it the right code, you gave it the story, you gave it even business context outside if you had to, right? You can link to a bunch of different things. If you've got documentation somewhere, you'll pull that in. Code obviously, story obviously. You made the ask a lot more clearer. While you initially asked for, give me any questions that you have, what you really meant to do to execute the story is, if you have assumptions, tell me that as well so that I can point out where you're going wrong, right? You can make that prompt more and more detailed. You can think of more things. You can ask for things like, tell me what my blind spots are. I've groomed this story. In my opinion, it's groomed well. What is it that I'm missing based on the code base? What have I failed to consider that you'd like to clarify as well? Because it can read the code a lot sooner than you. For example, you've never seen that code base if you just started, right? You can ask it to validate, like think through the code if you groomed the story for the first time, and it can tell you what your blind spots are. Or it can at least try to guess what you have not thought of. And you could say, yes, I've thought of it, I don't think it's a problem because of this reason, or say, yes, you're right, this is a problem, I need to make the story better. And this sort of collaborative nature between you and using one of these tools is actually going to make your story a lot better, a lot quicker. The next thing is, you explicitly asked it for clarity, making sure that the story has enough information to be able to execute. And if not, then ask more clarifying questions. And you made sure that you asked it not to execute anything until you had information. And this is one important thing. A lot of these tools are biased towards wanting to execute. And if you use something like Copilot, especially in the earlier days, you send a prompt to it. If you don't enable plan mode, for example, it will just start executing, start writing code. It's like, I'm asking you to clarify something or think through it. It's like, nope, no thinking, I just want to go and execute. So this has become better in later versions. So like clearly people are working on this all the time. But the point is, I think, knowing which part of the phase you're in, I don't want you to move forward until I have enough information, is fairly important. We talked about context for a second. I'm going to mention one other bit because a lot of people have this challenge. If you work in a larger product organization, for example, you might have a bunch of your business context or even tech context in documentation. And this documentation might be the tech documentation for the tech stuff and user-facing documentation for the business side. And these might not be in your repository, right? So if you're on a fairly large product, for smaller products, a bunch of people, how people manage this is they create markdown files in the repository itself. You might be doing that as well. The age-old example of having readme.md is a good way to start repository level context to begin with. But now if your repository becomes a bit bigger and has multiple packages, a common next step is, why don't I put package level readme.mds? Because each package has a certain business functionality and I can document that part inside the readme.md. It might be 100, 200 lines, but it's fairly easy to maintain, and let's assume you have the discipline to keep it updated. The tools will be better from it. Now, what if your product is even bigger, right? How do you make sure that this happens more consistently? Like I said, if you get to a public product which is fairly big, this documentation will move to an external website, for example, right? And it's also not something that is very easy to keep in memory. I did say contexts are limited based on the models you're using. If you're using something like Sonnet, for example, one of the more, the Claude models, they are probably one of the better models for software development right now, but they also have one of the shorter context windows. So it's an interesting combination. If you use something like Gemini, or the Google, side of models, they have massive context windows. But at least personally, I'm not a huge fan of the quality of the output just yet, right? It's good. There are times that actually, more recently, it's become better. But if you go to about 3 months back, they weren't as good. 3, 4, 5 months back, it wasn't as good. These things change fairly quickly. So I know if anyone's watching a recording, for example, 6 months from today, this answer might be completely outdated, and that's fine. But my point is that this changes fairly regularly. So if you have a model which has a lesser context window, you can't take your entire organization's document for every single story and load it into context. You don't have the space. And this is the question which gets asked most often is, how do I manage then? How do I make sure that I have the right information? And I don't want to get into the details of how to implement one, but look up RAG if you've never heard it. It's a fairly popular pattern, and there's others as well. But use something like RAG. Because effectively what it does is, if you want a quick visualization as an engineer, imagine you have a database and you make a query to pick up the right parts of the context and only load that in memory. That's what RAG does. That's what RAG helps you do when implemented properly. There's a lot more nuance into how you find the right context, how you load the right context. And if I were to explain that, I think this talk would just become like a RAG conversation, because that in itself takes a fair bit of time. But if you're struggling to visualize it, we can talk about that offline. Clearly seem to have clicked the wrong button on the clicker. So we're going to look at this transition of the slides once again. Sorry about that. So far, we've talked about how to look at requirements, how to clarify things better. While we've taken an example of how to clarify requirements, you can do the same thing with user experience design. You can do the same things with a bunch of the other analysis that you need to do. If you need to look at system level design, for example, you could ask, if you have a multi-repository setup, you could ask for a plan which talks about what are the different systems which are going to be touched, how you are going to change them, where are the changes going to be made, etc. You can keep going more and more detailed about this. I'll take some of those examples soon, but one of the key things you do at the end of sort of the plan phase is effectively ask it to clarify a bunch of specifications, as they are called these days, and you would have seen there's a bunch of frameworks nowadays to do specs. If you want to use those frameworks, great. If you don't want to, that's fine too. But effectively you want to, when you did a bunch of back and forth, right, that context has a bunch of information, there's an end decision at the end. Whatever your decision, this is the clarified requirement, ask it to dump it back to the card, ask it to dump it to a markdown file, your interface of choice. Because usually if your model has limited context window, right after this you're going to start executing the story. When you execute the story, you will run out of space. and context is fairly limited for, like I said, for Sonnet models. At least I tend to sort of clear context and start again. And so before I do that, all of the learning that we've had, I need to dump somewhere. So I can ask it to forget the back and forth conversation that we've had, but I can just take the crystallized output, which I really like, and just continue from right there. Okay? So let's move to the next phase, which is what happens during development. So in this phase, we'll kind of look at how you actually build and test. And I also know that probably for most of you, this is the area that you've spent the most amount of time in, so I might go a bit quicker on this one. But at the beginning, what did we pass through? We passed through effectively a clarified set of requirements, a spec of sorts, right? Either using a framework or not. If you have your custom style, that's okay too, right? Now again, let's go with the slightly lazy approach first, because I know I have been guilty of this the first time I started using these things, which is, hey, can you start creating an implementation plan? Here's the story, I told you everything, please go tell me how to implement. As you imagine, I think you've seen the trend by now. For an entire story, if I ask that, usually I don't get a great response. It'll give me 3 tasks, right? Add the invite UI, send invites, track everything, and make sure that people are effectively using the service. Which at a high level is okay, but it's fairly shallow, like I said, right? Like it does not have the depth of the thought that I would appreciate. If you take a fairly big story and then divide it into 3 very high-level tasks, it doesn't quite give me the confidence that you'll implement it correctly. I mean, it's correct in the sense that yes, you have to do those 3 things, but as a dev, are you getting the confidence that it will implement these correctly, right? Are you sure that the design is correct? Are you sure that the implementation, the quality checks are all there, right? This time we'll use a slightly different technique. We'll go back and say, let's do what is called a few shot one, right? And in this example, I'll say something like, hey, I need a more structured plan. The way I appreciate a plan being is have all of these things like goals, have the risks, the decisions, the steps, everything detailed out. And this, by the way, is also a fairly vague prompt. In real life, this is not going to work really well, but we'll come to that. It's better than the previous one. You'll talk about, follow this plan and then just please execute the story for me and tell me what the plan is looking like. And this time you'll get a slightly better output. This time it's kind of split everything out. You'll see that the steps are a bit more detailed. Look at the onboarding state, different states. I'm just going to the steps directly. The decisions, risks, etc. also are worth reading, but just in the interest of time, look at something like the steps, right? Like slightly better now. Please add the onboarding state machine, which is what's the life cycle of an invite, right? You will first invite someone and then they will accept the invite and they will get onboarded all the way, etc. Right? So you'll probably have a state machine there, etc., etc. Now it will ask you edge cases as well. It will ask you more clarifying questions, but you can keep playing this game. The reason I was saying that this prompt is also not super accurate is because we've not really asked what a good step means, right? Like how high level is high level? What level do I want to go to, right? So you could either now choose to accept this and say, yes, I will take care of the risks and everything else, I'll talk about it. But when it comes to the implementation plan, you could ask it again, save this into an implementation.md and let's start executing. And when you pick up the first task, please get more detailed, right? Like I want 3 level more details. I want to go into what classes you're changing, how you're changing them, etc. So you could save this as a plan and then execute. Or you could say, this is not good enough, I need more details right now. That's more of a personal flavor. I tend to be okay with something like this because, I mean, there'll be more tasks than this, but I'd be okay with something of this sort. And then when I pick up the task, I'll say, give me full details about what you're going to execute, right? Talk to me about the design, the choices that you're making, etc. But if you're seeing that I'm effectively applying the same technique again and again. So this time, because I used few shot, the next one will be save this plan, pick up first step, pick up the next task, create a plan, give me design, give me steps about what you would do, tell me how you would validate. I'll ask all of those questions, right? So example of this would be, let's say I'm a huge fan of XP, have been for a while now. So you might start with, I want to do sort of a red-green refactor, right? In this case, I'm going to drop XP for a while and just start with something like, please write a test for the invite flow first, because if I write a test, it will fail and then I can get it to work. So do it slightly differently. There are more efficient ways to do this, but let's say I'll say add a test for the invite flow. Now usually what will tend to happen is it will add a test because I asked to add a test. The problem is the test will be fairly vague. Now going back to what I was saying earlier, why is the output not great? The output is fairly high level because I didn't clarify what I meant. I just said please write tests. It made a choice on what kind of tests I wanted. Did I want unit tests? Did I want integration tests? Do I prefer mocks? Do I prefer using other kinds of test doubles? I didn't tell it anything. There are also styles of tests, right? Like, do you want to follow AAA, which I prefer a fair bit? I didn't clarify what I meant, so it will write the test that it wants. So quite often I've noticed that like the output that you will get out of tests, let's talk about a slightly better version of this, is when you realize that the tests are not good and you don't like them, you will then go and say, hey, can you critique the tests and write me a better prompt? Because I don't have the clarity on writing a better prompt sometimes. And this is the meta prompting technique I was talking about. I know I don't like it, I don't know why I don't like it. So you could go back and say, can you write a better prompt for me? And I've been a bit lazy here, but you'd also explain what is it that you didn't like about the test, right? You might not know the right words sometimes, but for example, I think one of my teammates was saying when they asked for a test, the test in the assert had an if case. It said if something, then assert this, else assert this, which to me is like, you should never have that situation. You should have actually had two tests. Because there are enough test methodologies where you can use either parameterized tests or something else. So now you've learned that there is an anti-pattern here. Ideally it would have known this, but again going back to it, it's been trained on data which is the entire internet. I'm fairly sure somebody's written a test of that sort. And just because I have a belief that I shouldn't have if conditions in my test doesn't mean the rest of the world doesn't. So let's give it the little bit of leeway and actually clarify what we meant better. So then go back and do the same technique, right? Go back and say, I didn't like the fact that you had if conditions in your test. I never want us to do this again. Can you look at my testing prompt and create a better one, right? You will do this like probably 5 or 8 or 10 times, right? Every time you find something bad. But like I said, it's a fairly powerful technique to get a structured prompt which works well. And I know people tend to go out on the internet and look for standard prompts and use them, which in most cases is okay. But then you need to tweak those too, because like I said, some of these are fairly team specific. Us as a team have like a view on what good tests look like. Like I know I have, and for those of you who worked with me, I know there's a few in the crowd who have, right? Like I know you have shared opinions about what good looks like because we work together. But I'm sure for those of us who've not worked together, if you and I sit down together, you will look at some of these tests and be like, what's wrong? I don't see what the problem is. I'm not saying any of you are wrong. You have a preference, you have a style, your teams do too, and so do ours. And that's okay. So the standard prompt to say, this is the one prompt which will write the perfect test is not going to exist. Because quality, or what we feel is acceptable, is different per person. I might come from a school of thought of having read clean code, right, and having worked with people who test a certain way. So those are my opinions because they have been shaped by the people I've worked with, who I've learned from. Yours might be different. There is no right and wrong. I feel my style is better. I'm sure you feel that yours is better. So we can't expect the LLM to know that until we say this is the kind of test that I want. So clarify. These are prompts that you will have to improve over a period of time. So it will give you feedback, right? When you ask like a meta prompt, quite often you will get feedback saying, hey, give me critique so that I could learn what I missed. So in this case, there was no clarity on what kind of test you wanted. You didn't tell me the acceptance criteria clearly enough. You didn't tell me whether I should do mocking or not. You didn't tell me expected behaviors. Some of these are on the card, for example, so that might not show up, but the stylistic parts definitely will show up here. So iterate on that a bit better, and it will give you an example of a better prompt. Now do this a few times, clarify more, and you will get a prompt which starts working for you in 70–80% of the time fairly flat. So yeah, after this, try executing the prompt, rinse, repeat a few times, and fairly soon you will have a style which works. Common issues that we've seen are failures in, for example, AAA, which is arrange, act, and assert, which is usually people who follow AAA will want to split their test into 3 very distinct sections. Right? Your act will be a single line to execute the thing, arrange is everything in the setup, and assert is all the asserts at the bottom. Ideally, it's one logical assert, not 2 different types of asserts, but an object might have 4 different things for you to assert in 4 different ways based on the testing tool of choice. But having this test divided into 3, for example, for teams that I've worked on, AAA is fairly sacred for us. So I have to tell it that. Test naming scenarios, some people will use underscores in test names in Java, some people don't like that. I'm not here to preach, I'm just here to say whatever your style is, please just tell it. Tell it that these kind of test names are acceptable for my team and these ones are not. It will follow, right? So yeah, so choose your style, start codifying it. The important part is to remember in this sort of phase of work that we're in, coding practices are not just going to be explained to each other as teammates. If you want your teammate, which is a computer, to also start understanding some of these things, and you're starting to treat it like a teammate, please explain to it in a language that it understands, which is better prompts which have clearly codified rules of what acceptable looks like. Because that's another major mistake that we tend to make when we use these tools. And then we complain about the quality not being good enough. Cool. Let's talk about really quickly in development. There's a few other patterns which work really well. MCP servers for automatic feedback. I won't go into MCP because I know I can spend hours just on that. I think next week, in 2 weeks' time, we have a speaker who's going to be here, Akash, who's going to talk about a bunch of the development stuff that I have skimmed over, and he's going to go into more details and show examples of this and like other techniques as well of some MCP servers that he's added to his workflow that really benefit him. But just to give an example about like sort of automatic feedback, if you're building for UIs, for example, this is very powerful. So you can come back and say, here's a mock-up of what I wanted. Can you build to that spec, right? It'll get the colors right, it'll get the layout right. But the thing is that it's trying to understand what the layout will look like without actually rendering the layout. It's reading the code. That's no different than you reading the code and trying to understand if your output's going to be correct. And have you ever built a UI where you thought the UI is going to look good, look like this, the mock-up, but it doesn't? Happens, right? Like we all make mistakes. These things do too, right? Sometimes the layout's not perfect. How do you give it that feedback? Now, you could either take a screenshot, paste it back in, it'll work. Or you can connect something like a MCP server, which actually gives it access to the browser. There's a bunch of different tools. The one that I tend to prefer personally is something called as browser MCP. Because I can give it access to that one session and it doesn't run with like an independent Selenium thing which actually runs a separate browser. The problem with a separate browser is it won't have my credentials, it won't have my logins, etc. So I'll have to log in every time, which I find annoying. So browser MCP, because it's in the same browser, it's already pre-authenticated. I just log in, it can see the page, it can move around if it wants to and get feedback. There are other tools too which come up all the time. Use the one that you want, but the point is then your tool has the ability to take a screenshot, understand what works and what doesn't. It will burn through tokens fairly quickly. So yeah, make sure that you have like a plan which is okay with this. But as long as you do, you will get better output and you will iterate a lot quicker. But this is not true with UIs, this is also true with APIs, for example. A thing that it is used to is, for example, doing curls. So as long as you've given it a token in some way and said, you know, I have a temporary dev token for you, use this, and you can actually talk to the system, it will be able to have that conversation with a curl endpoint and actually make sure that it's working well. While you will have unit tests and integration tests, if you need your pair to be able to use the system, please set up a mechanism in which it can actually use. You have to teach it how to use. MCP is one way for it to discover. You can also do this through prompts. You can write a prompt saying, go look at this, you can curl, here's a token that you will need, right? And you can go access. It will create the curl automatically because, you know, it can read through the code and understand what the REST request is, what the response should be like, etc. So you can do basically the equivalent of manual testing, right? If your automated tests are passing but your manual ones are not, then this is a good way to iterate over that fairly quickly. Another technique is making sure you have repository level prompt libraries. So what are prompt libraries? Just let's not mention this so far. I know I've used this word twice, but we've been talking about prompts, right? We've been talking about how you can iterate and make them better, tune them for your use case. Now, if you've tuned it for a specific repository, if I've taken the effort of building a prompt which gives me really good results to write good quality tests as my team wants them to, why would I not want to share it with a teammate? Why should you have to redo all of that effort? Why should you have to do one and get a slightly different output and not have that be consistent? Right? Wouldn't it be nice if we can actually share? So most of these tools have a way to be able to check in that repository. Each tool is different. Claude has a .claude directory that you can create, and there's a structure in which you can add some of these commands as what is called as a slash command. There are other techniques too, but there are ways for you to basically be able to share it at a repository level. So if there's anything project specific, put that context into that repository so that everyone on your team gets access. They start up their Claude Code, they automatically have all of this available. Right? Your teammate will thank you for this. It's no different than having a setup which is fairly easy, fairly well done, fairly automated, where you just hit a single command and you're up, ready to go. Right? This will feel like that. Feels magical, makes things a lot easier. So if somebody else makes a push and improves it, you get it for free. Right? Good way to be able to work. And this is what I meant by codifying your, your organizational context. This is one of the things that I meant. The extension of that is, we talked about repository level ones. You obviously think about the next level of abstraction is, why does it have to be repository level? As a team, I might have 3, 4 repositories, 10 repositories I work across. Right? As a department or as an org, whatever your next level of abstraction is, why don't I have, prompt libraries at that level? Of course you will. Some prompts don't have to be specific to the tech that you're using. It can be shared across the org. For example, a prompt on a meta prompt, for example, on helping you improve prompts is usually going to be fairly common and reusable across your org. So yeah, have one which is fairly common. Again, there are distribution mechanisms. Things like Claude have a very, very easy plugin architecture, which is basically create a repository, ask everyone to set up like a single command once, and it will install the prompts and it'll keep it up to date as well for you. So there's a full distribution mechanism. There are a bunch of other ways as well, but choose one. But make sure that you're, having common sort of prompts across your org. The next sort of level in this space is doing a multi-agent setup first and then a multi-agent setup, because everyone wants to dream of the day when, like I said, you can run a prompt and then just go and play table tennis or your favorite, foosball or whatever else, your favorite game. But effectively, like a multi-agent setup can look different in different contexts, but you're trying to set up an agent to be able to plan really, really well, right? Like we've tuned it to be able to look at all of the aspects of our business, make sure we're tying in all the context and it's able to create a great plan. You'd want to then do development. Like I said, like personally, I'm a TDD fan. I do red-green refactor quite often, but your style might be different and that's okay. Follow your development workflow. You don't do any automated tests, don't do one. You do automated tests with a different shape, size, more integration than units. Great, do that. Right? This is not meant to be prescriptive. All I'm trying to say is figure out what your style is. For me, that is something like a plan agent, usually a set taking care of red-green refactor. Sometimes actually there are multiple agents as well. And you would want something which gives you automated reviews as well. And then take that review and feed it back. Right? I mean, how else will you do refactor, for example? You need to do a review on what you've changed and then feed it back in, refactor, and then kind of run everything. This is usually my workflow personally. You create your own, but effectively this setup will actually make it a lot easier. It's not like you can now get up and just go do whatever you want, but there will be blocks of time when it is executing stuff where you can do other things. So I know there are devs here who have worked on multiple stories at the same time because their role has become more for reviewing stuff, which is plans, reviewing the implementation, etc. They spend more time in doing that, almost like, I don't really love the term, but classically what a lot of people call architects. And in the past, at least people who've known me for a while know I don't like that term for a reason. But yeah, people are spending more time in being able to actually review. It doesn't mean that you don't code, you will, right? But there are parts of the problem which is like some of the heavy lifting or the base implementations can be taken care of by the system, and then you kind of improve on it. You're still not vibe coding, just to be clear. It's not like you're sending a prompt and just getting up and going away. If you think that vibe coding on production is a great idea, I think we should talk at the end of this. It's not. Please don't do it. It's still your responsibility to do the right thing, but to do the right thing, I think you can take a fair bit of assistance. So whether you use that extra time on, on doing multiple stories, or doing a slightly different implementation, which is sometimes I've been on a call and executed a story, more productivity, so good. So let's talk about the last part of the sort of development section that we've been on, which is looking at sort of the release part of it, which is, this one's going to be fairly short, but I'll take an example of once you build something, at some point something's not going to work. Just because you've done everything doesn't mean your software is going to be perfect. Sorry, if that wasn't obvious already, I should have called it out. You're still going to have challenges, things are still going to break. Because inevitably the system's asking doing the best that it can based on the context it has, and so are you, right? You can make mistakes, so can it. So when you have a bug, what do you do, right? So if a test is failing, for example, think about why it's failing step by step and help, solve this problem. Is a fairly common prompt. And if you've not done this already, you should also try just giving it a stack trace once. It's tons of fun, especially for people who are not great at reading stack traces. If you're, a bit younger and have not trained your eye to, not read but scan through a stack trace. I know for the people who've been writing software for a very long time, you're used to reading stack traces and you don't even actually read them. You just scan through it and you know exactly which parts to read. These things kind of accelerate that for you because it's like a nice cheat. Take the stack trace, put it in, it'll actually find issues a lot quicker. Now there's two parts I do want to talk about. One is, the nice part of this is that it accelerates the rate at which it finds issues. I usually don't do this all the time because I also want to not fall to the other problem, which is I want to continue to have that skill to be able to read a stack trace. It's very important. And if you've not learned that skill yet, you're fairly younger, please don't over rely on this technique because if you do, you will never build the ability to scan through stack traces. And I know so many people who struggle with reading stack traces that it is something you need to practice. Build the skill, it will be useful because I feel like using LLMs to do it all the time is basically like throwing money at the problem. Like I have enough money, I have enough tokens, just throw, dude, it'll be fine, it'll give me the answer. It does mostly. The places where this becomes really interesting is if you've got a multi-threaded app, for example, right? And you've got those nasty threading issues which are very notorious to try to debug. These things are great at doing that. These things are also great at issues which are 4, 5, 6 levels deep, or there's an error in the framework that you're using, but it is because you misconfigured something and it's not obvious, or that issue doesn't happen all the time. It's not easy to reproduce. These are all things that, like, I know that I would have spent 4 hours, 6 hours to do, and there have been times when I've actually spent like 5 minutes to actually fix. And 5 minutes is an exaggeration because I just took the stack trace, sent it over, and it gave me an answer. I'm like, it can't be that simple. So there was this issue I was fixing where I kind of gave it the stack trace and said, here's what's happening. I'm not sure, and here's the flow that I triggered. Here's what's happening. Here's the stack trace. Can you help me identify what the issues are? And it gave me 5 issues, right? I asked it to prioritize as well. Give me issue number 1, 2, 3, 4, 5. I looked at issue 1 and tried it out. It didn't work. Gave it issue number 2. It worked. Now the thing was, I still didn't understand why it worked. So I had to so it took me 5 minutes to fix it, and the system was up again. It took me the next hour to read through the documentation to be like, oh, now I get what the problem actually was. So again, another request is just because you've gotten to the fix doesn't mean that, I mean, you can ask it for an explanation, it will give one to you. So you can ask it to fix, then ask it for an explanation of why this helped. But do spend the time to make sure you understand it, because building a better understanding of your tech is fairly important. Because that's what sets you apart as an engineer. Otherwise, you're just like doing whatever the system's asking you to. So yeah. Remember, You're not asking the system to just write code. You're asking the system to start thinking with you. That's a key mindset change, right? You're not delegating, you're using its help. Okay. So I know we're at an hour. I just wanted to check really quickly. If you guys are okay, I'll take another 10 minutes or so and talk through some patterns, anti-patterns, and we can close this out. We can take a break, and then we can go on to sort of spending some time with code. Right? Is that okay with everyone? Cool. So last 3 sections. By the way, all this time it might be hard to see, but at the bottom right corner, there's a small section there. So we're about 6 of 8. But this is the sort of conceptual part of it, which kind of steps back. While we've talked about implementation, we'll now talk about patterns, anti-patterns for devs, what you should keep in your mind. This is some of the learnings that we've had over the last year and a half. Most of this stuff is published on like our website as blogs. One of them I know is about to come, so you might not find it offline, but that's okay. You'll find it soon enough, in a week or 2, it'll be up. So first is for anyone here who is sort of building teams. This is if you are a team lead, a director of engineering, a CXO, whatever else, anyone who works with a team and feels like, hey, my responsibility is to enable the team to do a great job. This is some of the advice that I have for you. First is please focus on value. It is very easy to feel like I should focus on velocity optimize for quickness of delivery. The tendency for a lot of people tends to be to look at, hey, earlier I could do this story in 2 days, now I can do this in a day. Yay, I saved a day. But that's the wrong thing to focus on. Please make sure if you're a stakeholder who's trying to build an engineering team that you're focusing on value first. That my quality becomes better, that my systems are getting more robust, more stable. The reason I say this is because there's going to be ups and downs in this journey. The tooling, like I said, changes all the time, right? And that will require constant investment. So if you're looking at just velocity as, as a raw number or pace at which you're delivering, that pace will sort of wane in and out. Any major release, any major shift in tech, there'll be things that your teams have to relearn. And at that point, you will get fairly disappointed. Hey, I'm not consistently getting the velocity that I wanted. It's the wrong metric to look at. Velocity is the outcome, right? Like you will get it at points. Focus on value. My system's better in quality. My analysis is better today. My design is more consistent. I'm having lesser issues with vulnerabilities, for example. Right? My quality overall is becoming better. My test case quality is becoming better. While I don't love the coverage term, but that's becoming better, for example. All of these are better outcomes. Please don't just look at velocity. Second, please factor in the learning curve. Right? Like I talked about, like on day 1 when you show up, you might have heard a lot of this stuff, and if you've either started using these tools already, or if you've not, right? I would say go home, get a license, play with it, right? Experiment on a code base that you sort of work on your own time. If you have got an open source repository, you contribute to use these tools. You will notice that in the beginning, it doesn't make you faster, right? And in fact, the more senior you are, the more you will feel this. You will feel more tempted or more frustrated in the beginning to say, I am quicker without this. Why am I having to do it? There are moments I'm very, very quick, and there are moments that I'm not. And that will probably want to frustrate you a bit, and you will want to stop, right? Please know that if you're sort of someone who's building a team as well, your team will go through the same thing. You need to teach patience, you need to be okay with some of these things. And you need to change your expectations. Day 1, there isn't going to be teammates who are just flying through stuff. It takes time. It takes investment of someone's effort to teach. So take that time. Expect that learning curve. That learning curve tends to be about 2 to 4 weeks. Slightly different for different people, but sometimes even 6 weeks. But that's the time frame in which you'll start seeing things getting better. So it'll get worse before it gets better. Next is quality guardrails are a prerequisite. You don't have good enough tests, you're going to struggle because you will generate a lot more code than you ever have. And there is no guarantee that also it is going to be good or even working for that matter, right? If you don't have a good, robust review process, it won't work to begin with. And if you don't have enough safety nets, my recommendation is, why don't you start with adding the guardrails first? Add the guardrails and then later work out how you can, make things faster in other parts. Okay, but do not think guardrails are an optional thing, right? If you feel like your manual QAs are the only ones who will exist in your org and they will take care of all the quality and quality as an afterthought, it's not going to work. And I'm sure you've heard enough stories about issues on production with AI generated code. A lot of that is because quality is not a pre-thought, it's an afterthought. Please don't do that. Autonomous agents are really far away. I know there's been a lot of hype, at least, 7, 8, 9 months ago. I felt like if I opened LinkedIn and I saw any post, right, like half of them were on one extreme or the other, which is everyone's going to lose their development jobs, or it's going to be great to be a developer in the future. And if you ask one camp why, right, they'd be like, of course, like you have these tools writing code, so why will we need developers? This entire role is going to end. I don't think that statement's true. Not that I have a crystal ball to see the future or anything. If I did, then I'd use it for better things than try to predict this. Here's my opinion. What is it? I think it was 2014-ish or so, maybe a bit earlier, plus minus a few years. We started seeing self-driving cars, right? Or at least experiments, closed loop experiments where people were having cars which drove themselves. It's been over a decade, right? For those of you who came here on a bike or a car or a cab, was there someone driving it, yourself or otherwise? Yes? Did anyone here show up in an automated cab which didn't have a driver? No, right? It's been a decade. You saw multiple demos of it happening, but a decade or so later, there are real world edge cases which take time. And I know people are working hard at it. I know there's been progress. Like if you go to California, in certain parts, you can take a Waymo which has no driver, right? And for people who sit behind it, it's like slightly nerve-wracking in the beginning, but it's an interesting experience, I'm told. I've never experienced it myself. But I'm saying equivalent to that, this is going to take time too. It's not going to happen overnight. And if you are worried about it, please don't. Right? If you are the person who is wanting to outsource your thinking to the tool, yeah, maybe you should be a bit worried, is what I feel. I think if you're someone who augments their thinking process with these tools, I think you'll be fine. So pick up slightly different kinds of work, but don't get as worried about just everything is going to end. Watch out for a lot of what is called AI slop, large amounts of code being pushed through, not great quality. And usually if you're seeing that in your org, go back and think about some of the other techniques we talked about, right? Are my organizational repository level prompts good enough? Do I know the right techniques to be able to refine them? Do I have guardrails in place which could have, if they're not catching, if they're making its way to production, then guardrails are missing. Use that as feedback, right? But if you don't do this carefully, there's going to be some people who will get burnt. So if you're someone building teams, just be careful about some of this. This one's a bit more high level. There are going to be changes to responsibilities over a period of time. What we do and how we do things. One of the examples I like to take is actually not dev-centric, but this applies to devs too. Some of the business analysts I've known over a period of time, we've had, like I've worked in orgs where there have been business analysts and there have been product managers, right? And both of them are great at what they do. But as time, or project managers, and as time goes on, their roles are starting to kind of blur because there was a bit of an overlap between the two in some cases. There are tools which will automate parts of that responsibility, make it a bit easier, and then you say, why do I need 2 people for this? Like I can merge the functions because they're overlapping anyway. In some cases, like product managers also look at the product, business analysts look at it slightly differently. I know this is not a like for like, but there are some overlaps and you'd say, maybe I just need to merge the roles. That's one example. This applies in a lot of other places as well. So some of that is going to happen over a period of time. So if you're someone who's building an org, think about some of these and what the progression of your people, your growth of your people kind of looks like. This doesn't mean that people necessarily get let go of, it just means that I think your roles evolve over a period of time. And for, those of us who know Sahaj a little bit, internally we've been, for the last 11, 12 years, for our entire existence, we've had only one title, for example, solution consultant. We don't really have For example, developers which are different from BAs, which are different from QAs. And coincidentally, in this case, this advice kind of follows the same thing, which is we felt that there were overlaps and we could make it a lot more efficient if we had one person kind of covering everything. And we're seeing some of that play out now with some of this tech coming in. So yeah, so if you have an org, just watch out for some of these things. Last bit is be a bit careful about reduced decision making. It becomes very easy for you to, like, how many of you have gone to ChatGPT and just asked it a question and said, can you do this for me, and then like not thought about it? Because it feels easier, right? Like cognitively less load for me to not think. Just I've given you the context, why don't you do the thinking for me? Be a bit careful of that, because over a period of thinking is a very, hard skill. It takes a lot of energy and your body's tuned not to want to do it. So your brain wants to be in type 1 thinking, if you know type 1 versus type 2. If not, there's a nice Veritasium video, I think, which explains this concept. But your brain doesn't want to think deeply. So when you ask it to make decisions like, but why? It's like so much effort. Why should I do this? But also you lose this skill over a period of time. Be very, very, very careful. And you'll also get a sense of lack of ownership. So you ask ChatGPT to make your decisions, you ask Claude Code to make your decisions, soon enough you'll be like, this is not my work though, it doesn't resonate with me. So people who've asked like written essays themselves versus outsource the job of writing an essay to ChatGPT, you come back and ask them what they feel about their work. The first group actually feels attached to their work because they built it. And it's the same IKEA effect, right? Like if you built your furniture, you feel attached to it. If somebody else did it, you're like, okay, it's a thing, somebody wrote it, it's nice, I'm sure, but you don't feel attached, you don't feel like it's your work. And we'll talk about what that means for people on teams soon enough. But one of the first things I've kind of talked about already is please treat the tool like the system like a new teammate. Please don't just say it's a tool and ignore it completely, right? When it misses something, be patient with it, give it more context, figure out what you didn't tell it, which is why it produced the wrong output. Spoken a fair bit about that one. Do smaller chunks of work. It's very easy for you to now go and say, I know we talk about short commits all the time as devs, but this is required now more so than ever. Otherwise you can send one prompt and just be like, 1,000-line PR, go, right? And for those of you who've done, I'm guessing most people here also have done code reviews, right? Like PR reviews, yes? Do you like a 1,000-line PR coming to you? No, right? So please be nice to the person sitting next to you when you send a PR, like make it more logically smaller, easier, smaller chunks of work. Because if you had to self-review, you would need that. So please do the same. We noticed that the average PR count kind of started going up because it's just easy to write code faster than ever before. So people are just produce, get it done. But that's not quite the bar, right? The idea is not to just produce code. It's to make sure the code is good, make sure that it actually works. So smaller chunks of work, please, so that reviews are easier. Create your own teams and team-specific rules, codify that context. We've talked about this already. Shift in sort of time spent on responsibility. For example, like earlier, I would spend more time in writing code than thinking about it. Like I wouldn't spend as much time in tasking stuff out, as some people call it, the planning of the story. Because inherently, at least to me, in most cases, I would know, I'll do this first and I roughly know a path from, to complete the story. And most of you, I feel like, would feel the same, right? Like, how much time do you spend, sometimes 5-10 minutes just to think about high level, I think these are the things I need to do, and that's it. You don't go into the details. But I've now started spending more time in making sure I have the right clarity, I built the right spec, because the quality of my execution depends on it a lot more. And because as a human, I'll make runtime decisions and it'll be fine. But with these things, because I can produce code a lot faster, I want to do it in the right way. So I'll spend more time in thinking. That's just one example. There'll be other shifts that you will notice as well. This is similar to the other. This is a mirror of the other side. So even if you're a teammate, please don't over rely on outsourcing that thinking. You need to focus on doing it yourself. So let's talk about principles. So far we've talked about some of the things to watch out for, patterns and anti-patterns, right? That's what that last section was. Things you should do, things you shouldn't do. But patterns and anti-patterns are based on principles. So we were trying to think about what are some of the principles. Why are we seeing the same patterns? Why are we seeing these same anti-patterns? And we came to like a list of 5. Okay. Simple one-line statements. Each of them has a one-line description as well. Right. The first one is, AI augments your thinking, but you are still accountable to what you're doing. Who's doing the commit? Whose name is the commit going under? Right? When the thing doesn't work on production, who's responsible to make sure that it gets fixed? Right? If you outsource, that's not the thought process, but here it is. So please make sure that you are still in control. It is your accountability that the system is built correctly. If it's not, then I mean, Copilot, for example, has I forget the name of the feature, but it has a thing where you can write a story, just tag it, it will generate a PR and just accept it. Right? Just have a product manager, kill the entire development team and ask it to just do auto PRs. And soon enough, what orgs will realize when they go down that route is it doesn't quite work. You have a bunch of induced issues, bunch of quality issues, and the system has become very brittle. Right? So that line of thought doesn't work. But if you as a human are doing the same thing, you are ending up causing the same side effects. So just be very careful. Know that it is your, for lack of a better phrase, neck on the line. You are accountable to this. Second thing is that context is everything. The quality depends on the clarity that you have. If you don't know something or if you can't tell it clearly enough, you won't get a great output. If you don't quite have the vocabulary to be able to explain something, that's okay. You can use techniques like we talked about meta prompting, right? You can get it to build slightly better prompts. But if you don't know, then neither will it. Right? So give the right context, please. The next is that the smarter the AI, the smarter your guardrails need to be. So the more we rely on AI to generate ideas or code, right? We looked at both the pre-development, the development phases in like a little bit of detail. The stronger our review and validation process also needs to be, right? So while, for example, I suggested I prefer having a review agent, I never implied that I wouldn't be doing a review as well, or that my teammates won't be. That still exists because I am outsourcing a fair bit of the execution. I still need to be the person to hold the line. It's my accountability, like I'm accountable to the output that we produce, right? So I'm going to spend the time to read through everything. I'm going to spend the time to say, is this the code I would write? And if not, I need to question it critically and think about it. These habits need to be stronger now more so than ever. So if you are a team who didn't spend as much time doing this, this is one of the big changes that's going to happen. Okay. Next one is that you should shape AI deliberately and not let it be the one which shapes you. It's very easy to let it shape your decision making. Please don't. Choose when to use AI. Choose how to use it. While it will influence some of your process, right, like the way you operate, don't let it define who you are and what your team's culture is. Right? That is something that you need to still hold to. And the last bit, which again is an assumption that we, like a thing that we've noticed fairly recently, is that people think that I will learn these tools once and I'll be done with it. I'm sorted, right? Like I learned IntelliJ like a decade ago. I read the release notes every quarter, and that's enough for me. But with these things, the releases, well, about 6 months ago, there was a daily release. Now for Claude Code and stuff, it's like a weekly release, mostly a monthly release. And yes, I can go just do that. But then the models internally also change. It's not just the tool which is changing, the model is as well. The way it answers changes. The way it reacts to the same prompts also change. So the prompt, just because it was working today, doesn't mean it will work tomorrow, because the models itself will evolve. So you have to account for all of this. You are going to retrain yourself. Like I said, like 6 months ago, I'd only used Claude. There are now some cases for which I'll use Gemini too. Because when I need larger context to be able to analyze something, Gemini is a pretty good model to do that. There are times when I use GPT for creative writing because I prefer the way it writes and cross things more so than the other two tools. So I'm not beholden to one style of writing, but knowing the nuances is important, and continuously learning and understanding what the next new thing is coming in is important. You need to invest time in that growth, and it won't just stop with the part of the journey we talked about, right? There's other dimensions like I mentioned. So the last bit, the closing message, made it through, right? We're here, like it isn't that AI builds software, okay? AI is helping you sharpen engineering. The tools will change, but your thinking will endure. The thought process doesn't. That's the key part you're trying to cultivate. It's very easy to feel that we are just using tools, but there's more to this than that, because engineering is not automation. And the next thing is intelligent engineering has a bunch of things. One of the important things is that you spend time in codifying your engineering culture. Earlier, engineering culture was just shared between people as a conversation, or reverse engineered through the code by looking at the style of code that we produce and then trying to replicate that over a period of time. Now it's important to also codify them as rules, as prompts to clearly say what you need, right? You start by creating simple prompts, then use meta prompting to make them more and more structured, create shared prompts through your repository, and over a period of time abstract them. There's a concept where you can abstract them as well, and then eventually create org level prompts as well. The second thing is also, hopefully you've taken out of this talk, is you don't just use this for just writing code, but you use it end to end across your software development, right, through every single phase. The real mind shift isn't that AI is writing code for me. It thinks with me. It's one of the key takeaways I want you to take. It is assisting you to think differently. Quick summary of what techniques we've covered, right? Structured thinking, and then convert them into good prompts. Provide the right context. Meta prompts and chain of thought scaffolds are fairly powerful if you use them correctly. You can use it for AI-assisted debugging as well, including on production, local, etc. And you need guardrails and clarity first. These can't come later. This is a practice, it's not a trick. Practice takes time and conscious effort, and you need to invest into it. Lot of people, I feel, because of that hype of all developers are going to get replaced, like there was an existential question I felt, and I thought I should talk about it. So we should talk about who we are as people, right? Our job is not to be prompt writers. Our job is not to be tool operators. Our job is to be more intelligent engineers, right? That, I'd like to thank you for this talk, and I can take any questions that you have.
So we talked about stories, like writing a better stories, or what is the approach, what should be our approach to write a better story. So let's say we have a meeting with our stakeholders where we have a VA at all. So we have the meeting recordings with us, scripts are already ready with us. And so rather than going for maybe a chain of thoughts or this approach, can we use AI agent to directly attach that scripts and all, and just giving a prompt of these are the main headings from where I have to create some stories. Let's say 4 headings. I have to create 4 stories. Just do it for me, and then let me know what you need out of me, to any questions you need out of me to refine the story. So what should our approach in that perspective?
So summary of the question, I'll just repeat the question and paraphrase it. Just let me know if this is correct or not. Also, it's easier for the recording, I guess, if I do that. When you do meetings, most meetings are recorded these days, or at the very least transcribed, right? So can we put the transcription back into one of these tools and ask it to generate the story for me? Do I think that will be more clearer? Will it be better in terms of outputs, etc.? Right? So I want to talk about 2 bits there. Did I get the question right, first of all? Yeah. Okay, excellent. So I want to talk about 2 bits. First, I think that's a very good use case, and we've tried a bunch of that. I know a bunch of people do. There's one thing I want to talk about, is it good or not, directly answering the question, and want to call out one risk that we've also seen, just be a bit careful about it. I think it's an incredibly powerful technique. I think it helps accelerate a bunch of things, including making sure that you're building the right thing. Now, there's a massive asterisk I'll add to the answer. I'm a huge fan of that technique. Just be a bit careful, because your the quality of the answer is proportional to the quality of the transcript. The quality of the transcript quite often is not as good as we think. Different tools work differently, and so I can't claim to have tried every one of them. But I was reading reports about some paid tools and their quality not being great. We use Google Meet a fair bit internally, and that has a Gemini thing integrated. It does transcriptions as well. I've been to meetings where it has transcribed the meeting because one of our teammates couldn't make it to the session. He later said, hey, I'll catch up by reading the transcript. Now, transcript has two parts. Transcript has literally, the document that it captures, Gemini captures, has two parts. It has the transcript, which is almost like subtitles, which is at this time of the meeting, this is what was said, this person said this, etc. So it has that entire conversation, and it has a summary as well. So personally, what I tend to do, because time efficiency, you'll go read the summary first and then read the transcript if required. Big mistake. So here's what happened with my friend. He read through the summary, and he then, like, him and I were talking like a day or so later in the evening, and he asked me, Acha, so this is what we decided, right? I was like, no, that's not what we talked about. It was literally the exact opposite of what the summary was. So I was like, where did you get this from? Like, who told you this? Like, either I've misunderstood or somebody else has mis-summarized it for you. And he's like, I read the Gemini notes, and that's what it said. And I'm not trying to knock on a product here, right? And it'd be interesting to debug why it did that. I went through the summary, so my friend wasn't mistaken. That's what the summary had. So he read it correctly. The summary was incorrect. And I'm like, why is this happening? Then I actually went through the call because I was there, so I know roughly which section I needed to read, right? I read the transcript, but transcript was more or less correct. It had some mistakes in there. And because it doesn't pick up voice perfectly at times, I could hear everything, but it didn't transcribe it correctly. The summarizer on top of it summarized and in the most extreme example, and this happened, I've only seen it once just to be clear, but it was the exact opposite of what we talked about. So if we said we want to go north, it said south is where we should go. And that shocked me. Now, what do you think will happen if you have a transcript with a mistake like this going into the story? Story will be incorrect, right? So the warning I wanted to add for you is, we've noticed like problems like this happen, and the second thing we've noticed is when meetings are recorded and transcribed, most people tend to avoid going to meetings because they're like, dude, I can read the summary in 5 minutes. It'll save me a bunch of time. I can skip the meeting. And I dislike meetings as much as the next person here, okay? But I must warn you, one of the problems we've seen happen as a result is people tend to not have the context that they need to in our heads. So if you look at the people around you and the people you worked with who are really, really sharp, have you ever asked the question why they're this good at what they do? Right? Have you worked with someone who's been on the project for a while who just like, you ask any question, instantly they will have an answer for you. They know exactly what was built, why it was built, how it's built, they know those things. And if you think about why, right, they've been around long enough, they've heard enough to have remembered every key decision. And it's built as a map in their head. So when you ask them a question, they know which part to pull up and then be able to answer. And that's a very good tacit skill to have. And it takes cognitive effort to remember it regularly, right? It's a memory problem, it's a bunch of other things as well, right? But a lot of attention goes behind it. And as we start outsourcing to these tools and say, hey, I do have transcripts, so technically if I have transcripts, then I can build a database of transcripts with a search engine on top of it, yada, yada, yada. I can have all context in one place. I do want to warn you that it doesn't always work like the way we want to, because you're only as good as the quality of the transcript. And the transcripts, while there's been a lot of improvements in that space, they are not perfect. So under the assumption that they are correct, yes, good technique, it will work. You still need human review. So it all comes back to the same thing. If you review it well enough, you will catch it. So my friend in that day was talking to me, so I corrected his thought process. So like we didn't make a bad decision based on that. If it was a story, read the story, yada, yada, right? Like you're getting the point of what I'm talking about. So please focus on that. Trust it, but don't completely blindly trust it, because there are issues with it. And someday maybe the transcription models will get better. I know some of them for offline transcriptions are pretty good. I know people here who have worked on a fair bit of voice to text, for example. But for live transcriptions, there are still challenges in the generally available market especially. So be a bit careful. as long as you are doing manual reviews and all. Otherwise, the idea is pretty good. Answers your question? Cool. Any other questions? The back there, please.
Hello. Yeah.
Hi.
Yes, sir. Actually, there was this dilemma that we came across every day when we are using AI. I would like to give it in the first person example so that it clarifies. So let's say you mentioned about the guardrails, right? To protect and to review before integrating anything from the AI. Is that idea correct of guardrails to evaluate and review everything before integrating in your code base or making decision? So ultimately, it all comes down. Yeah. Has proposed ultimately your own decision. So do you think?
Yeah, so I think, so let me repeat your question. I know voice dropped out for a second, but I'm just hoping that I get this correctly. You have all of these tools who are now helping you make these decisions. How do you strike a balance between the options that it's giving and our ability to choose? Like our ability to choose the right thing, right? That's effectively your question? Okay. Take AI away from that discussion for a second, right? I know it seems hard, but take it away for a second. Let's say 5 people around you are a team and you have to make that decision today. Ask the same question. 5 of you probably have 6 opinions on how to do that, right? 4 if you are less opinionated and 6 if you are 6 or 10 if you are really opinionated. You have multiple choices. How do you choose? How do you choose what is the right one? Because I don't think that choice has that ability to choose has fundamentally changed. I'll tell you how most people I know and most teams I have worked with have made these choices. You list a bunch of decision parameters. Okay, let me take a context, otherwise the answer will become too vague. If you're doing a design decision, right, you'll say, my overall system is like this. Here are the functional and non-functional requirements. So basically putting a bunch of constraints into the system to say, this is a shape, you can't go outside this line because it's not valid. For example, if you come and say, one of the rules, let's randomly make one up, saying you have to use Java for a solution, let's say, right? That's the only language which is allowed in that ecosystem. So for you to propose a Python-based solution will not be accepted, right? So that's like one of your boundaries of your solution, and you can add a bunch of other constraints. Now every decision you will say, anything which is inside that shape, right, which meets all the rules is a valid statement. Fair? After that you will come back and say, which one is better? Well, better in what dimension? What's the dimension which matters to you more at that time? Because all of them are valid. So out of, let's say 10 proposed solution, let's say 7 of them are invalid for one reason or the other, 3 are valid. How do you choose the one which is best? Well, it depends on what you're prioritizing or what are the set of things you're prioritizing as a team. And usually most people I know sit down and talk about solution A is better for these things, B is better for these things, C is better for these things. And then there's a subjective decision on what you feel is better. And quite often 2 people will disagree. Let's say you and I disagree on, you feel A is better, I feel B is better. We'll debate about why we feel one is better, and usually one of them will just say, okay, let's do it your way. Right? And there's usually a decision making protocol on most teams I've been on. Either one convinces the other, or you do a vote around the room, or if there is no other thing, I've seen quite often, you allot one person to have a tiebreaker vote in the room, saying if there's a deadlock and we can't break it, whoever this one person is, we will choose. And usually that person's the one with the most amount of context. Right? We like, I mean, everyone is making a judgment call. If it's not an objective decision, then it's a subjective one. So the one with the most context is probably correct. Doesn't mean that they're always right. That you're taking a bet on that. I mean, this is one algorithm I've seen teams apply. You could have any. But what I'm trying to say is this decision making has not changed whether you have AI or not. I just look at that system being another person in the room, so to say, another opinion, or 5 or 10 actually, realistically. So apply the same lens, make the same decision. That makes sense? Cool. Sorry, can you be a bit louder? I'll repeat, or just take the mic so it's easier. You could do that too, yes. On systems which allow you A/B testing, you can implement both and you can test them. If the decision is fairly expensive, then less so. And to his point, I think this is what he was trying to imply, because the cost of development is going down in that sense. The speed at which you can build things is higher. There's a very good chance you could do both. Now for some systems, for example, it will be harder. If you're building like a banking system and this is around transactions, yeah, the risk is a lot higher to do this on production, but you could do that on other places, right? And you can do a test environment, test it, and then look at it for sure. Do a performance test on a proper environment and check what happens. There's other experimental ways to be able to scaffold it, but yeah, absolutely. Cost of development being lower, you could experiment with more than one solution. Yes.
So nowadays we are hearing this news of AI bubble is going to burst. I was going through some of the news, and on the other hand, we are also getting this news of AGI is our future. So
Sorry, what was the last one?
artificial general intelligence.
Sorry, can you make it a bit closer? It's hard to hear you.
AGI is going to be our future. So why these contradictory things are going on in the
Oh man.
market?
I think this is, I'll give you my, like I said, I don't have a crystal ball. So I'm going to read tea leaves and give you my opinion. Not that I'm like the foremost expert in the space. I think people debate about whether the bubble exists or not. The debate has widened in the last, 4 weeks, with I think it was a New York Times article which talked about how every company just invests in the other and bumps up the valuation. Don't have an opinion on that, right? I think there is a fair bit of hype. It is probably a bubble of sorts. The valuations are a lot higher. I'm not great at valuations, so I don't know if they're fair or not. Not my place to say. If I was a multi-billion-dollar investment firm, then I would have an opinion, but I'm not, so I don't have one. But the hype exists. I can see why it exists. I see there is value. Whether the numbers being quoted are correct or not, I don't know. And if it's probably not, then it is a bubble and it will burst a little bit. But what I'm trying to talk about is, I'm not really worried about the hype. I'm really worried about what is the value we can take out of it. And that is why the things I'm talking about is, like, this is stuff you can take back to work on Monday, assuming you work in a place where you have access to these tools or are allowed to use these tools, or a bunch of other checks, right? If it is, right? Or if you write code over the weekend to, learn, etc., you can do this today. Go home today and start trying these techniques out. I'd love to hear your opinion, because that part's not hype, right? The other part of your question on whether AGI is coming or not, I think there are people incentivized, making the statement are also incentivized in you believing it, so I don't know. I think true AGI is hard. Apparently GPT-5 was supposed to be that, PhD level. In some topics it is fairly smart, but I don't think it's quite what we talk about. I let the data scientists in the room have that opinion on whether we're going to get there or not. At least I feel a bit skeptical about it. But again, like I said, my job as a technologist is to find what value I can find, right? I have no incentive in sitting here and hyping stuff up for you to believe that there is this big picture where X is going to happen. My job is, here's how I can find use today. I can be better today. And in 3 months' time, do I think something's going to happen? Like, for example, I am decently bullish on MCPs being a slightly bigger thing, but I don't think it's the next big thing. That's my personal take on it. I feel a lot of these techniques that I'm talking about are probably going to stand true for the next 6 months to a year. A list is going to grow. You ask me this in a year or two, I'll tell you more patterns and anti-patterns. There's more levels of abstractions. I've not gone into things like slash commands, like taking prompts, making them slash commands, taking slash commands, making them agents, taking agents, making them multi-agents, even though I just really quickly talked about it. You can do a lot more, right? I'm sure there's going to be more. There's a concept called skills which have been recently added. All abstractions will be added. Fundamentals will remain the same. I'm focused more on that. I'm not here to try to sell something to you. I have no incentive to. I have I mean, dev days in general are that, right? Like us telling you what our opinion on tech is. So take this information, use it the way you want. I'm not sure about the AGI thing. Personally, I don't think it's coming, but if it does, then great. I mean, we'll figure out what we do then. So yeah. Anyone else?
So in your workflow, and First of all, like it was
Hi.
a very insightful session. So
Thank
in
you.
your workflow, I have just seen this. You do have this plan agent, and then say second one is this like the
Red, green
green,
refactor.
refactor agent. Then you have the review agent, right? So what is this like the red green refactor agent?
Yeah. So red. So what he was asking was, in case anyone didn't hear this, in one of the slides I was talking about plan agent followed by RGR, red green refactor, and then review. So red green refactor is a term you can look up, by the way. It's a technique which has existed since the days of XP or extreme programming. There's an entire book about this. A bunch of us have come from a school of thought where we've learned that some of these techniques are useful. So red green refactor is this idea where you say, I will not write a piece of, so first thing when I do is I will write a test, TDD, okay, test driven development. I will write a test first and run it to make sure it's red. Because if it's green already, it's already implemented, that thing that I'm trying to test.
Scope is limited, na? So if
It is.
Yeah.
So you iterate, right? So you first write a test which is broken, then you write just enough code to make it green, right? And then you say the implementation does not have to look great, it just has to work. So it is make it work, make it right, make it fast, right? So that principle. So you make it work first, and then you say, but the code's a bit messy, like I hacked something together to get it to work. I will refactor and make it better, right? And to refactor, sometimes you need someone to be able to review, right? Like how do you know what to refactor? How do you know stylistically what is not right? Well, that's what the review agent's for, right? Feedback.
Okay.
And you keep doing this. You do one part of the requirement, then the next, then the next, then the next, and kind of build the whole system out. Now, this again, because I come from like a TDD school of thought, I like thinking that way. I feel it's a very good way to build stuff. I know everyone doesn't ascribe to TDD. Like I said, if you have a different way, if the most classical way that I know a lot of people tend to do this is, I will write all of the code first, then I will write all of the tests to make it work, and I will hope that I've covered every single acceptance criteria, and maybe just do a story review and check whether all the ACs are being met or not, add a high level test and do it. If that's your way, then that's your way. I'm not here to judge, I'm not here to tell you whether that's right or not. You set up that pipeline the way you do development. That's all I was trying to say. So if you want to look up red green refactor, look up XP, look up TDD, there's a nice book, read it. You have a different way, implement it that way.
So sir, so what I used to do is like I do the research in maybe GPT-5 because it have a long context, and then I do the planning with the technical, maybe the cloud Sonnet 4 or 4.5 thinking mode again the chain. And so I never use the TDD method yet because so maybe so adding some level of a memory or what would you say, the set of a rule to make the TDD and then doing the implementation, is that a good way? Like.
So I have like a set of prompts that I will tend to like restrict. So to say, you put in rules to say until there's a run the test, make sure that the test is failing, only implement the bare minimum code to be able to test. All these are like almost statements straight out of the TDD book or definition, right? So I'd have those. In terms of the choice of models, if you wanted to talk about it, I think using GPT for planning and then coming here, your logic seems to be sound. I do it a bit differently, but the logic I use is the same. I tend to go Opus for planning, or used to at least, to primarily like Opus for planning. Opus is the largest model that Claude has. Because I use Claude Code, it's in the same context, it's easier for me, just like / command and it switches. Implementation is I keep it on auto mode, so it will automatically switch between Sonnet and Haiku. So Haiku being cheaper because it's the smallest, and then Sonnet being the slightly bigger one. I felt that it does the auto job for development really well. Planning also Sonnet does pretty well. Now that 4.5 has come out, the documentation or the claim seemed to be that Sonnet 4.5 has like capabilities that Opus had earlier. So they're basically taking the big model and taking its capabilities and being able to take it to the one level down model and bring it there. So effectively at a cheaper cost, you're getting better quality. So at some point they will also upgrade the Opus. So for now, I'm not using Opus, I'm just on Sonnet, but the point is that give it some time, they will come up with the next Opus and be like, guys, we made Opus 4.5, which is better than the previous Opus. Right now, Opus seems to be a bit pointless, unnecessarily. Why would you want to spend that money, right? Because Sonnet is giving you that capability. Logically, I'm doing the same thing as you, is what I'm trying to say. I'm saying just your choice of model will change. With every release, if you see a release note, you're like, cool. And this is why it's important to know your principles, right? Don't just blindly, what I don't want you to take away is, Karun said use Opus for planning, Sonnet for development. No, I'm saying know the reason why you're using it, which is the exact same thing as you, which is for planning, larger context window, better models for thinking. So I want to use something like that for plan, create that plan, move it in. You're using GPT and then you're having to transfer it manually and that breaks your workflow. I'm not a huge fan of that. I would want to use one tool. So if you're using something like open code, for example, and that allows model switches between orgs, or you're using, what router is it called? I forget the term. Open router, I think it is, right? If you're using open router and open code, it becomes a lot easier for you, right? In open code, you say, choose model GPT. You can do the exact same thing without the context window break. You can follow all of the other techniques I talked about, like creating a plan MD or a spec file and then, using it further. So set up your workflow accordingly based on what you feel more comfortable with. I'm not trying to be prescriptive about that, primarily because I know it will change, right? In the last 12 months, I've changed 4 different opinions on the types of models you should use. But that's bound to happen. The models change that quickly. What am I supposed to do? So this advice is going to age like milk, the part of what model I use right now. But the advice on the logic to choose, which is what you're saying, I think that stays supreme. So focus on that.
Sorry, last question. I'll give another chance, but it is interesting session. So in the planning or the research phase, I would say, so how would you use the RAG? Because I use the indexing. So in the cursor, you can index the documentation if there is a large document, so that it will use less context, but it will have the index of the document. So I would be interesting to know like how RAG would be used there. Like
I think one of the sessions we're going to do, not the one that Akash is going to do in a few weeks, like in 2 weeks time here, but probably we're planning something in Feb. This is me letting a cat out of the bag. One of the things we want to talk about is like be able to demo that to you guys, because we've set it up in a few places, but short version is logically it works the same way as the indexing in cursor. So what you will say is when you send a question, so if you can paint a picture, if you know the tool sets well, imagine you have your coding assistant with a MCP to give it access to some of these APIs, right? And in the back, you have like a RAG system built out, where if you ask a question here, it will go fetch and it will return. That's like the logic, right? So effectively, you're saying, when you don't have context, here's a knowledge base which has context. So if my prompt doesn't give you the right context or enough context, you need to seek more, please check here once. And if good documents come back, now you will be like, should it just be RAG? Should we RAG with re-ranking? Should it do a bunch of other advanced techniques to make sure that you're scoring it correctly, that you're weeding out? Because in RAG, if you ask a question, even if you don't get a great hit, you'll get some hit, because vector search will give you something. But you need to put a threshold on that and actually filter when you don't have a good enough. All of that is still true. None of that is going away. But all that's also more effort, right? So like for anyone who's built a RAG and like knows the nuances of this, you will know that there's a fair bit of engineering which will go into just that. So that's why I don't want you to start with the idea of this sounds cool, so let me go set up a RAG. A, most people don't need it. Most code bases are not large enough. More organizational contexts are not organized enough that you need something like this. So, and like, I mean, if you've noticed the name of our org, it's called Sahaj. And for those of you who don't know it, it means simplicity, right? We believe in building simple solutions. So I don't want to stand in front of you and say, build this super complicated thing which is hard to maintain, when for a significant population here, a simple markdown file or a collection of them is going to take care of it, right? But for the larger ones, absolutely. If you're in a massive bank or whatever, right? I'm sure you have documentation for days on historical stuff about why features are built certain ways. Dude, RAG it. Like, I think it will make it a lot better. Put it in there, get it indexed. As long as you get right results, it will be a good thing. But yeah, trade-off is engineering, a lot of it. So you better have someone who knows how to do it well. Yes.
Hey, hi Karun, this is Nilesh here.
Hi.
So we talked about leveraging AI during development, building effective test strategies and writing test cases. So I have one question on real world scenario for testing. It's more related to QA automation. So we have a scenario wherein we have to automate almost around 5,000 to 10,000 test cases, right? But the challenge here is we don't have manual test scripts. So writing those many manual test scripts manually is not at all a feasible or advisable option.
Yeah.
So leveraging AI tools like Copilot is the feasible one.
Yes.
How will I ensure that whatever Copilot recommends or writes in form of test cases, is those test cases the right ones? How will I ensure the test cases correctness? At the same time, how can we ensure that whatever Copilots and AI tools suggest, they are covering the enough coverage from testing perspective?
Yeah, it's a really good question. In case somebody didn't hear it clearly, summary of the question is, if I have a large code base where I don't have good enough guardrails, safety nets, how do I make sure, and using something like a Copilot is a very good way to accelerate that, because I don't have thousands of hours to sit and do this. How do I make sure that the quality is actually good? Because it could produce anything. And I was smiling through that question was because it probably will produce stuff which is pretty bad, okay, to begin with. And that's why I was talking about some of those techniques. But let's solve that problem step by step, because I know it's a very, very real problem. I did touch on some of the concepts, but I think we could have a more detailed conversation, probably spend an hour just on this, right? But again, I'll take the same approach for the solution as I took for the person right next to you, right? What would you do if you didn't have AI? If you and I were having this conversation 2 years ago, 3 years ago, 5 years ago, how would we solve this problem? You'd still have that issue. You'd still say, I have some test cases, but my manual QA team doesn't have like a long list. Our releases break, etc., etc., etc. And for anyone few who've done projects which, like, at least I use the term legacy modernization, this is a very serious problem, right? Like, entire engineering teams have spent years just making this better, right? That time is going to get lower, but the fundamentals are not going to change. So some of the fundamentals in this space would be, first identify what right looks like, which is hard. I once worked with a product which was in a financial org, which was older than I am. It still is, I guess, right? I mean, the product's still there. So as far as I know, it's still there. So the product is older than I am, right? So it was written like early 80s-ish, really, really old product. And you can't, like, easy answer that a lot of people just say is like, just throw it away and rewrite it. You can't. That system every night runs batch jobs which clear over, I think it was 100 million on the worst day, and on the best day, sorry, not 100 million, sorry, 100 billion, no, sorry, not 100 billion, what is it? Sorry, I think 100 million and 1.5 trillion on a good day, right? That entire extreme, because it runs effectively trade across borders for one of the key systems in that entire space. So it does bulk transaction of money movement between banks and reconciliation and everything else. So stakes are very, very high. And you go and say, okay, cool, I need to make a change. Every change is going to take, as you can imagine, months, because very critical system. Every change is hard to do because nobody knows the code. The code base is very, very old, right? So there is no person, most of the people who wrote the system might not be alive, let alone working in the same org. The best people who know most about the code have been there for 5 or 6 years. 5 or 6 out of what, like 40 some years of experience? Like, do the math, that's not a lot. So there are blind spots. So what do you do? What would you do as a person, right? You would go say, okay, I'll take a section at a time, I'll put safety nets overall, I'll do strangulation if you know the technique, right? Strangler fig, if somebody wants to look this up, there's a technique called strangler fig. There's also a good technique called, GitHub wrote this blog post about experimentation engineering a long time ago, which I'm a huge fan of. And in this case, we ended up using it, which is basically, I will have an old system and new, and I'm doing a strangler, but I don't trust my new system, but I do trust the old system. So I will run every single thing I have to do, I'll run it through both systems, and after the fact I will check, because mine might fail, so every failure I will log, every success I will log, every error also I will log, and I will look at time also for both. So I can then know if I am fast enough or am I significantly slow in performance, and I can do every single analysis without ever touching production. So same job, because it runs twice, mine just doesn't get connected to the output, it just writes to a backup area. I can do that analysis and get a report saying, even if it's a live system or a batch system, I'll get that analysis. Now you have a sense for how much percentage of requests are you getting right versus not. And then you keep pushing that up all the way till 100, right? But this is an E2E test. It's not really like the test that we would be talking about usually. Now that you have that, then you would start pushing tests down. Right? If you've worked in legacy modernization, you've heard these terms before, right? So you add a very high level end-to-end net, and then you keep pushing the test down. And if you're a pyramid guy, then you make a pyramid. If you're a trophy shape, test guy, then you make that. I mean, every team has a different opinion on what is the right thing for that problem. You choose your structure and you push tests down till you get a structure that you are happy with and you feel adds sufficient nuance. This answer, now let's talk about AI. None of this changes, right? The process can still remain the same, right? It can help identify what you have already. If you have a few test cases, you know, what space they're in. It can help execute a lot quicker. It can help you think through making choices like what he was asking, right? Make choices of which technique is better. You'll get to the same place, but you know, some of the fundamentals don't really change. And this is why I said, like, this is not magic. This is engineering. Like, you still exist, you still need to do the same set of practices. It's just you're going to use tools to make it quicker, to make it better, to help you spot opportunities that otherwise you wouldn't have. Like, for example, let's say you are a test pyramid guy every time. And when you're having a conversation, let's say I'm talking to one of you and you say, hey, in this situation, I shouldn't do a pyramid, you should probably do a trophy shape test case. Or you should do inverted pyramid or anything else, right? You and I would talk about why. Now, I'm doing the same thing with the AI tools, so getting more perspectives on it. That's the part which changes. Core engineering skill doesn't. So all of the amazing stuff that, like, I have read over the last, whatever, 2 decades, still holds true. More so now than ever, because I need to make decisions. So that doesn't change. And if you don't have those, then you can discover that knowledge a lot quicker than I did. I had to talk to people to learn. I had to read books to learn. You still have to do both of those. You just also have a third, another person, if I can call it that, to tell you that stuff.
Karun,
Sorry.
that's one question.
We'll take one last question. Formally, we'll close down the session. Casually, you can have as many questions after that.
Yeah, I'm still here, guys. I'm not headed out.
We'll take one last question, and then we can carry on to another. Like, we can have food, or you can have casual conversations with him, with anyone around us, etc., etc.
Maybe a brief answer. So this is very informative. I think we are mostly looking at the LHS, right? Something before coding, before development. There's something after coding, like build, deploy, release. Probably that could be a topic for another day, because there's a lot of automation already there.
Yes.
So I don't, but still, things are challenging even after automation. So AI can definitely help. But I think in brief, if you can tell for all of us this benefit, what does Sahaj do? I mean, you have products, services, Sahaj.ai also.
Oh, okay. Cool. Slightly different question than what I was expecting, but I'll answer it nonetheless. Sorry, his question was, what do we as an org do effectively, and how does that fit into what we were talking about? We are a services org. We are not a product org. So we don't build stuff to sell. We do custom software development for our clients. So clients will come and say, I have problem X, right? Like taking that fictitious flow track example, somebody comes and says, I want to build flow track. Here's my vision of what I want to do. Can you help do the heavy lifting for the hard parts of the problem? So we're also in sort of the niche space of picking up really hard engineering problems and helping solve the core of your business, the tech problems for your business. So we won't do like every piece of work. We're not like, for example, we don't do mobile dev, right? We don't do much web dev either. There are cases where we do UIs and stuff as well, but not in as much detail. We do hardcore engineering, and we focus on doing stuff in sort of core problems in platform engineering, data engineering, and data science. These are sort of our 3 areas. And the way this talk kind of relates to all of that is that this cuts across all 3 of those, right? Like, so we solve engineering problems in 3 places, three types of problem statements, right? Like platform engineering, data engineering, and data science. But irrespective of what you're doing, you are still building software. And so this whole intelligent engineering thing that I was talking about, this cuts across software delivery all the way. And we found it fairly useful when we built products for our clients. And we feel like there's a lot of other people who build software, either for product companies or otherwise. And you might find some of these techniques useful too, which is why we were sharing them. Does that answer your question? Okay. Cool. Okay. With that, thank you so much, everyone.